First off, for this question, if you know it's parametric equations, you know it's going to be parametric differentiation, and it's just the principle about if you want to prove that, because they're asking to show that dy dx equals to this, it's something clearly involving the variable t, and that comes from doing, so you can't do this question unless you realize dy dx comes from doing dy dt first, multiplied by dt dx. And then you'd realize dy dt, well, you don't need to be told that dy dt is something you can find over here, versus dt dx comes from doing 1 divided by dx dt. Because type in 1 divided by any fraction in your calculator and you know it gives you the reciprocal, right? You know that dt over dx comes from dx over dt and doing 1 divided by that. So this is just the baseline understanding you have to do for this type of question. If you don't know that, then there's no way you can approach this. Now with that being said, let's calculate what dx dt is and dy dt is. So we clear that these are the two things you need to start off with to be able to do this question. And without further ado, you realize this is the same thing as doing x equals 2. Because there's no direct formula for this on the formula sheet. You realize the only way you can do this first is to rewrite it. When do you rewrite something? When there's no direct formula for that. There's no direct formula for 1 over cos t. You'd realize the same thing as what? X equals to cosine t to the power of negative 1 on the outside like this. And this is the rule where, I like to simplify this. Whenever you have a bracket involving some type of variable, the differentiation is always pretend the bracket is a regular variable and you multiply the whole thing. Just do one extra step, which is multiply by the derivative inside that. Meaning if you want to find dx dt, it's just a two-step process instead of one. Meaning if you were doing x equals to t to the power of negative 1, like easy example, dx dt, you're not confused about why it's going to be negative t to the power of negative 2, just like that. So you pretend that bracket is a regular t, that same way, right? Negative of cosine t to the power of negative 2, but you must multiply by what? The differentiation inside, as the one extra step for this special rule. It's called the chain rule, but you know, like I like to think of it as just a two-step process. You pretend the bracket is a regular, whatever that variable is, and just multiply one more by the differentiation inside. And differentiation inside in this case is just going to be negative sine t. And you don't even be told this can be simplified, can't it? It's going to be negative, negative, positive, sine t over... I mean, it just makes sense why you would simplify this. Like that. So just leave it at that for the time being. Just like dx, dy over dt, excuse me. dy over dt is just going to be... Isn't that the same thing as doing ln... So it's ln tan t. Isn't that the same thing as doing... Pretend the bracket inside. Tan t is just regular t. Imagine if it was ln t, right? It would just become 1 over t. So to see how the differentiation works. You just pretend that bracket is a regular t, so dy dt is just going to be, for this one, is just going to be 1 divided by ln t. 1 divided by, excuse me, tan t. Because imagine if it was just ln x on the inside. Do you know what I mean? Like there's a direct formula for ln x. ln x becomes 1 over x. So ln tan t just becomes 1 divided by tan t if you're doing pretend it's a regular variable scenario. But you must do that one extra step, remember, for this type of rule, which is, aka chain rule, which is multiplied by whatever the differentiation inside that bracket is. What is the differentiation of tan t? Derivative of tan x is what? It's on the formula sheets. If you go to MF19, you'd recognize that tan t differentiated, aka tan x, because it shows you tan x, right? But you get what I mean, tan x, tan t, same thing. It shows you that tan x gives you sec squared x. And this is where you'd go with. So remember what we have so far? We have dx dt equals to sine t over cos squared t from the first part. And we now have dy dt is going to be equal to 1 over tan t. Put a bracket there so you don't get confused with the t's. Multiplied by what? Sec squared t. And then you'd realize, well, so sort of here's the intuition here. You'd realize if you're going to combine dx dt and dy dt, you wouldn't need to be told to, why not make them all sine and causes then? Because you know this can become all sines and causes. So you know 1 over tan t is just going to be cosine t over sine t. No confusion there. This is really basic stuff. Just like sec squared t is just going to be 1 over cos squared t. And then, oh, okay. And let's not divide by variables just yet. Let's not cancel our variables by dividing them just yet. Let's just keep this, meaning it's going to be cosine t divided by, we agree with the algebra over here, no problems. This is the most appropriate because we want sines and causes, sines and causes. And the next step is just going to be dy over dx. Isn't that just going to be dy dt times dt dx? That has to happen first, right? We recognize that relationship because that's how we're going to overall combine these to show this. We have dy dt now. That's why we did this in the first part, which is cosine t over sine t cos squared t multiplied by dt over dx. Isn't this just going to be this thing flipped? Cos squared t over sine t, like this. And it's like, you know, you just trust the math over here. Like, you don't need to be told, well, that clearly can be simplified, can't it? It's just cosine to the power of 3t divided by sine squared t over, excuse me, multiplied by cos squared t. And come on, like, look at this. Doesn't that perfectly just cancel out to cosine t? And that's how you get it, cosine t over sine squared t. That's all there is to it. If your friend who studies supposedly so much, and he couldn't do this question in loops, It is proof, right? Do you see how there's no opinion to this? It is proof that he doesn't quite get parametric. Like, he doesn't quite trust the algebra process. At least at some point, like, there's some aspect of the algebra elimination process that he's just like, fuck. Shit, I wouldn't think to do that. Whereas, like, look at everything we've done so far. What I want you to focus on here is, like, how exactly does a very competent student, someone who's very up to date with algebra, right? Someone who's a very high level of intuition you would expect, how can he not do this question? Where did the question would have gone wrong? It would have been from the sine t and cos squared part. When you were doing dy dt, you forgot to sort of have the awareness when you're doing dy dt. I'm just explaining to you, this is what you need to pay attention to here. What enabled you to solve this question where your friend couldn't? You can solve this as long as you realize by the time you do dy dt, this should be simplified into something involving sines and causes. Because you know they have to be combined together, they're multiplied together. You cannot simplify things when they're not even the same variable, are they? If you got sines and causes over here, and then you got secs and tans, how's that ever going to simplify? Whereas you'd have the awareness that if you have tans and sec squares, of course it's much easier, and you know it's possible to make it cosine and sine. Combine those, and then of course you're going to prove that dy dx equals to this.